Hello and welcome to this short video, Control of Listeria in Food Premises. My name's Andy Bowles and I'm a food lawyer. This video is the 23rd out of a series of 100 on UK food law topics that I'm delivering. You may be watching this on our YouTube channel now, or indeed as part of our online training service, which is available on our website. If you're watching the video on our website, then you might want to have a look at the webinar, which is about an hour long and goes into a lot of these issues that I raise on this short video in a bit more detail. Okay, so Listeria. Well, there are lots of different species of the bacteria Listeria, but Listeria monocytogenes is the one of concern. This is a food poisoning bacteria and it has a number of characteristics that make it quite difficult both to manage and control in food industry. One factor is that, and I have already mentioned this on previous videos, Listeria monocytogenes can grow at refrigerated temperatures. It's also capable of growing, albeit very slowly, in packaging where the oxygen has been removed. So for example, in vac-packed food where you've removed the air from a plastic pouch and sealed it up with the food in it. Listeria monocytogenes can grow very, very slowly in such environment. As I say, it can grow at refrigerated temperatures, so clearly it's a food poisoning bacteria of concern in refrigerated vac-packed products. But it's not just refrigerated vac-packed products, because it can grow in the presence of oxygen, so in normal air conditions. It can thrive in cooked chill foods, refrigerated foods, a whole range of foods. But it's not just the fact that it can grow at refrigerated temperatures that causes the most concern about Listeria. It can also persist in food environments for many years. Even after you've taken measures to clean and disinfect the environment, you might find that Listeria colonies have managed to grab hold of the environment. They do this by forming things like biofilms, which are quite difficult to actually remove in a manufacturing environment. They're also capable of infecting the sort of environment where food processing is taking place. You might find Listeria present on pipework, on external floors and walls and things like that. So much of the control strategies for Listeria monocytogenes are about making sure the environment in which food is prepared is suitable, as well as looking at the food and taking steps to prevent the outgrowth of Listeria monocytogenes. Now, it is a food poisoning bacteria, and the infection that it causes is listeriosis. Now, I used to work in the dairy industry back in the 80s, and I remember then Listeria hysteria, as the sort of red top newspapers called it, because at that time Listeria was becoming well established into food supply chains, particularly in dairy products and cooked chilled products. But whilst it sounds really scary that you can get listeriosis, which can be a significant and dangerous disease in vulnerable people, the reality is that instances of such food poisoning are thankfully quite rare. Looking at this graph behind me, you might not be able to see the numbers, but it's looking at cases of listeriosis in England and Wales from 2006 to 2015, and the numbers have persisted about the same sort of levels. But if you look at the left hand, the sort of y-axis, it's talking about a small number of cases, maybe 150 to 200 cases a year. Of course, that's significant for those 200 people involved, but when you look at the nearly 400,000 cases of foodborne norovirus, or the getting on for 80,000 cases of salmonella every year, 200 is obviously pretty low. So we have to put all of this in perspective. So it's a tricky microorganism, and Listeria monocytogenes can survive in quite difficult conditions. It can survive at temperatures close to 0 degrees centigrade. It can survive at very acid conditions, a pH of 3. It can survive in very dry environments. When I mean dry, I mean talking about water activity. AW is a symbol used, if you're not familiar, for water activity. roughly speaking, it's the water available for microbial growth. If you put bacteria into a salt environment, for example, it might be moist, the food, it could be a bacon or something that's salty, it's quite moist to the touch, but the water's not available to the microorganisms because the salt prevents them from actually getting hold of the water. So a 0.91 water activity is actually quite tough conditions. You won't find many other food poisoning bacteria able to survive those sort of conditions. And salt content, I mentioned something like bacon, a salt content of 20 to 30%. Listeria can survive in those conditions. It won't grow in those conditions, but that is a very salty food. But it can grow at pH levels as low as 4.4, which is still quite acidic. It can grow in salt concentrations up to 14%, which is still very salty. And it can grow at temperatures between 1 and 45. Clearly at 1 degree centigrade, growth will be very slow. So there are some foods that are vulnerable. Actually, there are certain foods that are more, I suppose, likely to have Listeria monocytogenes contamination. But remember, it's an environmental pathogen. It can appear anywhere in the environment. It could be present in a food factory or in a kitchen. So it's probably not appropriate to think of specific foods as being vulnerable to Listeria monocytogenes contamination. All foods are actually vulnerable. The issue is, if Listeria monocytogenes gets into a food, could it grow? Can it grow to a level to cause food poisoning? So I'm going to call a high-risk food with respect to Listeria a food that is possible, if it gets contaminated, could lead to food poisoning. So the 3 key factors. The first is it must be able to support the growth of Listeria monocytogenes. On the previous slide, I showed you what the growth was. In other words, the salt content, the water activity, the pH, they have to be suitable to allow the bacteria to grow. If it's very salty, it's very dry, it won't grow. Secondly, shelf life. Listeria monocytogenes needs time to grow. Typically, if the shelf life is less than 5 days from time of production of the food to consumption, that isn't sufficient time for Listeria to grow. So if you've got a cooked meat or something like that, and it's consumed within 5 days of production, then that can be seen as a significant control for Listeria monocytogenes. Also, the product needs to be ready to eat at the point of potential contamination with the bacteria. Again, if you've got a cooked meat, the process of normal cooking will kill Listeria monocytogenes. It doesn't form spores, it doesn't protect itself, it will be killed by normal catering temperatures, pasteurization, normal thermal processes used in manufacturing of things like cooked meats and cheeses and so forth. But if there isn't a further heat treatment, so you're in a factory now, you've cooked your ham, and now you're in a part of the factory where you're slicing the ham is not going to get any further heat treatment. It's at that point the food is vulnerable and high risk, because if Listeria gets onto that ham, it will be able to grow on ham, certainly. There's nothing to stop it in terms of pH, in terms of water activity, lovely conditions for it to grow. If it's a ham that's going into vat packing, well, remember, it can still grow in vat packing, albeit very slowly. But if it's a ham that's going to be supplied on to consumers and kept at refrigerated temperatures, if the shelf life is greater than 5 days, then Listeria monocytogenes can grow to a level to cause food poisoning. So you can see how foods can be vulnerable. Lots of foods can be vulnerable. Of course, there are specific foods that are well known to have an association with Listeria monocytogenes. Things like soft cheeses, things like cooked meats are more likely to be associated with it, as well as things like raw fish. However, one should never take your eye off the ball. If you're producing foods other than those, remember, if the conditions are right for the bacteria, it might be in the environment, it might contaminate at a later stage of processing, so you have to be on your guard. Okay, so how do you control Listeria in food premises? There's 6 main issues here. Prevent sources of external contamination. is clear. So in any kitchen, in any factory, you want to prevent contamination coming into the processing environment. If you're slicing your meat for service, you need to make sure that you're not putting, crates of deliveries coming that have been stood out in the rain into that environment. You need to make sure that your staff are not bringing in contamination. Design and layout. Physical separation between raw and ready to eat areas. If you're in a factory, proper control for people entering into these higher risk areas. Remember, Listeria can be in the environment. It could be on condensate, on pipework. So you might have Listeria congregating on top of a stainless steel pipe on the roof, on the ceiling. Normal cleaning doesn't get to it, and during production it gets hot inside, and so you get condensation dripping off the pipe. If that drips into your cooked chill food or onto your cooked meat slices, it might be inoculating those foods with Listeria monocytogenes. So you need to design out any potential for foods being contaminated. The product needs to be designed. Remember, normal thermal processing will kill Listeria. That's great. But after thermal processing, you need to think about, well, will it grow? Remember, the easiest way to control Listeria monocytogenes in a ready-to-eat food is restrict shelf life. So if you can restrict the shelf life down to less than 5 days and take all the other measures, put the other measures in place, you should be in a happy place with respect to Listeria. But you need to understand your product. So you need to understand if you're producing a ready-to-eat food that's going to go onto an elongated supply chain, like you're a manufacturer and it's going to go out on to supermarkets and go out to the consumer. You need to understand the controlling factors that might be present in the food, and there's a legal obligation for you to do that in hygiene law. If you want more detail on that, if you subscribe to our website, you can watch a webinar on the microbiological criteria of foodstuffs regulations. So product design is key. Cleaning and disinfection goes without saying, but remember, biofilms can form, particularly in a manufacturing environment. So you might have to mix up your cleaning and disinfection chemicals on a regular basis to stop Listeria establishing itself, particularly in pipework and in tanks, which are sometimes difficult to clean. Training of staff. Make them aware of the significance of Listeria monocytogenes and what makes it high risk and the controlling factors, because actually it's not that hard to control. And then monitoring. The thing about Listeria, because it can persist in food environments, if you have had a problem with Listeria, so you've identified Listeria in the environment, and you've taken remedial action to get rid of it, chances are it will come back. So monitoring environmental swabs can be very helpful, not just swabbing the drains, but swabbing pipework, swabbing around walls and ceilings, light switches, looking for trouble, looking for areas where there could be condensate, or there could be areas where the cleaning is not always as effective, underneath conveyor covers in factories and things of that nature. Of course, any control measure should be driven by HACCP. If you're not familiar with Hazard Analysis Critical Control Point System, well then you should be if you're producing foods that are susceptible to Listeria growth. You can go and watch the short video on that, or indeed 4 webinars if you subscribe to our online training service on the topic of HACCP. Thank you for listening. As I said, if you want to know more about the control of Listeria, you can sign up to our online training service. It is available through subscription via our website. That is just one of 99 videos that I'm producing on the topic of UK food law. So hopefully you'll join me on the next one. Thanks for listening.